My name is Farhan Ali. I'm in the summer of 2020 differential equations class, and today we'll be looking at problem 2 from homework 12. We want to find a particular solution for this equation here. We know this is a second order differential equation because the highest degree is 2 of y, and we know it's non-homogeneous because the right side of the equation is not equal to 0. So the first step is we want to solve for the left side of the equation. We'll treat it as if it's homogeneous for the moment. We need to create our auxiliary equation. We take our left side of the equation, transform it to our auxiliary equation, and then we need to solve for these r values. We know that a, b, and c is equal to 1, 0, and 4. We drop that into a quadratic formula. We'll solve for we'll solve for the r values, and we'll end up with 0 plus or minus 2i. We know alpha is 0, and then beta is 2. So we know this is a complex solution, and that's going to be case number 3. We can confirm this by going back and looking at our quadratic formula. I noticed that b squared minus 4ac was negative 16. That's less than 0. So we know it's going to adhere to our case 3 guidelines here. We know that in our case 3, our solution is going to look like this. And then we can plug in the alpha and beta values, simplifies to this. This will be our complementary solution. This is not complete yet. It's still missing our particular solution, which is going to be because the right side of the equation was provided with a value. So our final solution will be y is equal to y of c plus y of p. So we need to find this particular solution now. And then we can do this by taking a guess, actually. So we know that our right side of the equation is this equation here. And we can see that it looks like our case 3 forms. We confirmed that already by solving for the left side of the equation. And this will be our first guess. I'm going to use a times sine of 2t plus b times cosine of 2t. We set that equal to y. We take our first derivative and then our second derivative. We'll plug that into our left side of the equation, the original form. And we'll notice that all of these will cancel out and we'll get 0. Strategy here failed for this particular guess. So now I'm going to re-strategize by introducing a t into our guess to try to see if we can modify this equation to make it more usable. So instead of letting just be a sine of 2t plus b cosine of 2t, we introduced a t and distributed it, and we got at sine of 2t plus bt cosine of 2t. So for our second guess, we saw that we let that equal to that, and then we're going to take our first derivative and our second derivative. Those steps don't change. We'll plug it into our left side of the equation. That step didn't change. And it simplifies into this 4a cosine of 2t minus 4b sine of 2t. We didn't get 0 this time like we did in our first guess, so this is good news. I'm going to rearrange it so it actually looks just like our right side of the equation. Here, we set them equal to each other, and we can actually solve for these undetermined coefficients that we're looking for. We can see that a is going to equal negative 11 over 4, and we can see b is going to equal 1 over 4. So we take our original guess equation, and then we'll drop in these now determined coefficient values we can plug into a and b. And this is actually our particular solution. But it's not our complete solution. This is just a particular solution that satisfies the answer for this question. To get our final solution, we're going to plug in y is equal to y of c plus y of p. And all it is since we already solved for our y of c on the first step, and then our second step we solve for y of p, we just combine those two, and we get our final general solution with our particular solution that was given to us. This strategy only works if for those 3 specific cases that we're familiar with. Anything more complex than that, we really are unable to make our best guess, and we'll have to use different methods that we haven't learned yet to solve for those equations. But specifically for our 3 case equations that we know from our previous lesson, we can make an educated guess and be able to, using the solution that was given to us, be able to solve for those undetermined coefficients to create our particular solution. I hope that makes sense. Yeah. So in this case, we ended up with two guesses. Usually a t introduced into the equation will resolve it if you're pretty confident on your first guess. Otherwise, it may get a little messy. Yeah. Okay. Thank you very much.